This is the moving in example problem from the notes. In this problem, two people are pulling a 32 kilogram couch up to their second floor apartment. They're using ropes. One is pulling with a force of 177 newtons at 55 degrees above the horizontal, while the other person pulls with 203 newtons at 60 degrees above the other horizontal. We're going to find the acceleration of the couch after it leaves the ground. That means there's no normal force in this drawing. So step one, as always, is to draw the picture. I did that here. So here's my couch. Here's my 177 Newton force, and my 203 Newton force goes the other way. Here's my 55 degree angle. Here's my 60 degree angle. Force of gravity goes down, and I wrote down the mass of the couch is 32 kilograms. So step one is finished. We've drawn our picture. Step two, we need to make sure we know our positives and negatives. As per usual, I'm going to say that up is positive, down is negative, to the right is positive, and to the left is negative. Third step, we need to break forces into their components. So we have a force here that's at an angle. We have a force here that's at an angle. We need to break those into their components. So for the force on the left, I'm going to have an x component. I'll call that x1. And I'm going to have a y component that goes upward. I'm going to call that y1. So there's my x component, that's my left, and my y component, that's up. Over here, we also are going to have an x and a y, because this force pulls to the right. I'm going to call that x2, and it's going to pull upward like that. We'll call that y2. And we've got to find out what each of those x's and y's are. I'm going to start with my x1 and y1 forces. My x1, that is the adjacent side of this right triangle. So that means I'm going to use cosine in order to find it. Cosine of the angle, which is 55 degrees, multiplied by the hypotenuse, which is 177 newtons, tells me, once I plug it into my calculator, that x1 is 101.5 newtons to the left. Now for y1, that's the opposite side. So I'm going to be using sine of the angle, which is 55 degrees, multiplied by the hypotenuse, which is 177 newtons. And when I plug that into the calculator, I get that y1 is 145 newtons. We're going to repeat that exact process for x2 and y2. x2 is the adjacent side of the triangle. So x2 is cosine. This time the angle is 60 degrees. And the hypotenuse is 203 newtons. When I plug that into my calculator, I get that x2 is 101.5 newtons. y2 is the opposite side, so that's going to be the sine of 60 degrees multiplied by the hypotenuse, which is 203 newtons. When I plug that into my calculator, that tells me that y2 is 175.8 newtons. So I did my x and y components, found my x1, my y1, my x2, and my y2. Step 3 is finished. Step 4 is adding up my x forces and my y forces to find the acceleration of this couch. Now the x forces, x2 is 101.5 to the right, x1 is 101.5 to the left. They will cancel each other out, meaning there's no left and right acceleration of the couch, so I can skip the left and right. So we're going to worry about the up and down. In the up and down, I have my y1 is an up force, so I write that down. My y2 is an up force, so that's also positive. And I have force of gravity downward is a downward force, so that's negative. I'm out of up and down forces, so that's going to give me the mass, and we'll keep our colors consistent, put the mass in black, times the acceleration there in yellow. Now in order to solve for the acceleration, we have to divide the mass to the other side. So we would get y1 plus y2 minus force of gravity divided by the mass, almost forgot that, and all that's going to be equal to acceleration. From here I can plug in my numbers. y1 is 145 newtons. y2 is 175.8 newtons. Force of gravity is mass of the object, which is 32 kilograms times 9.8 meters per second squared. All this is divided by the mass, which is 32 kilograms. And that will give me acceleration. When I plug all that into my calculator, I find that the acceleration is 0.225 meters per second squared. And that is in the upward direction.